Hey guys, welcome back. My name is Miss Danielson and today we're going over integer multiplication. If you missed our lesson on adding and subtracting integers, I'm linking it down in the description box below. In that lesson, we started by clarifying some vocabulary problems I'm noticing in a lot of textbooks. We're going to start there again today, but we're going to go through it a little bit more quickly because we've already seen this. First of all, integers, to be absolutely clear, they are whole number, positive or negative values, including 0. Emphasis on whole numbers. They are not fractions or decimals. So although I made our title integer multiplication today, we will also be multiplying decimal values, both positive and negative. Then those decimal values could be considered rational numbers. Rational numbers are any whole or fractional number, including 0. And we can have positive and negative rational numbers. So there is no need for mention of integers in this title at all. But I'm seeing a lot of textbooks use the term integer to represent negative and positive values, but integers don't include decimal values. For example, these are all rational numbers. And to be clear on what a rational number is, they are numbers that could be expressed as fractions. 12, for example, could be written as 12 over 1. Negative 11 could be written as negative 11 over 1. 0 could be written as 0 over any value. Negative 0.5 or negative 5/10 could be written as just that, negative 5/10. Negative 8 could be written as 24 divided by negative 3? Why not? That would be negative 8 as well. 2.5 could be written as 25 divided by 10. Sure, that's 2.5. And negative 0.3 recurring, that's the same thing as negative 1/3. Right, let's get started with multiplying our rational numbers, whether they are positive or negative. You must know this rule. The answer will be positive. But that does not affect the operation that we're doing. Regardless of whether you're multiplying a positive or a negative, it will still be a multiplication that you're doing. When we talk about multiplying absolute values, that's when we ignore the plus or minus sign and simply multiply the values. Now let's have a look at a couple of examples. First of all, for question A, as you can see, it's a positive rational number multiplied by a positive integer. Since I know that these are both positive values being multiplied together, I know my answer will be positive, so I can ignore the signs for now and just do this multiplication. Quick reminder about long multiplication before we start. When we set up a long multiplication, remember to put the value with the fewer digits on the bottom, because this will give us fewer rows of working to deal with. Also, we can pretty much ignore that decimal point for now because we're going to worry about our place value when we get to the end of this question. So I'm going to multiply this through as if it were just 2 times 43. So I'll start by doing 2 times the 3, which is 6. And then I'll do 2 times the 4, which is 8. 2 times 43 is 86. But 2 times 4.3, to decide where to put my decimal, I know that my answer should have just as many digits after the decimal point as there are digits after the decimal point in the question. This question has 1 digit after the decimal point here. So my answer should have 1 digit after the decimal point here. Remember, it's positive, so my answer is positive 8.6. For question B, I'm multiplying a negative rational number by another negative rational number. Negative times negative will give me a positive answer. So I'm going to ignore the signs for now and just do the long multiplication. Again, setting up my long multiplication, I'll put the value with fewer digits on the bottom. And I know what you're thinking. It looks like both of these values have 2 digits. But negative 0.3 has only 1 digit, which is not 0. And when I multiply any value by 0, I get 0. So this is an easy one to work with, as there's only 1 digit that I really need to multiply through. So let's go ahead and set that up. And I'm going to treat this as if it's just 3 times 21, ignoring my decimal points because I'll worry about place value later. First, I'll do 3 times 1, which is 3. Then I'll do 3 times 2, which is 6. And it looks like my answer is 63. But obviously, 0.3 times 2.1 will not give me a big number like 63. Look at the number of digits after the decimal point in the question. There's one digit after the decimal in the number 2.1. And there's one digit after the decimal in the number 0.3. So that's 1, 2. 2 digits after the decimal in the question, 2 digits after the decimal in the answer. So my answer we said was going to be positive, and it needs to have 2 digits after the decimal place. That's going to be positive 0.63. What about when the signs are opposite? A positive times a negative or a negative times a positive? When the signs are opposite, our answer will be negative. So now that we know the sign of our answer, we can just go ahead and multiply our absolute values together. Let's look at a couple of examples. So for question A, again, I've got 2 rational numbers. One is negative and one is positive, so my answer will be negative. Keep that sign in mind, but just multiply the absolute values. So 2.5 times 4.2. It doesn't matter which order I put this in this time because both values have 2 non-zero digits. In addition to ignoring my signs, I'm also going to ignore my decimal points for now because I'll worry about place value when I get to the end. For now, I'm treating this like it's 25 times 42, starting by multiplying my 2 through. First, I do 2 times the 5, which is 10. I can put the 0, but I'll need to remember that 1, which is going to pass up to the next place value. Then I'll do 2 times 2, which is 4, plus that 1 makes it 5. And then I move on to the next row. So I finished multiplying the first digit through on to the next digit, which is 1 place over, which is why I need a place holding 0. Now I can do 4 times 5. 4 times 5 is 20, so I'll put a 0 here, and I'll remember a 2. Next, I'll do 4 times 2, which is 8, plus that 2 I've got waiting here. 8 plus 2 is 10. So I've got down here 50 plus 1,000, because 25 times 42 would be the same thing as 2 times 25, which is the 50, and 40 times 25, which is the 1,000. Add that together, and I've got 1,050. Now, obviously, 2.5 times 4.2 is not 1,050. I need to worry about the placement of my decimal. Remember our rule? Look at the number of digits after the decimal point in the question. There's a 5 after the decimal point for 2.5, and there's a 2 after the decimal point for 4.2. That is 2 digits in total. So my answer will have 2 digits after the decimal point. That'll be my 5 and my 0. And I know that my answer is negative. So that's going to be negative 10.50. Note I put my 0 here very lightly in green because it's not necessary for me to write my trailing zeros after a decimal point. So that's negative 10.5. On to question B. Once again, I'm doing a positive number multiplied by a negative number, so my answer will be negative. If the signs are opposite, my answer is negative. So I'll ignore the signs and I'll just do that multiplication. I can even ignore the decimal points and just treat this as it's 17 times 58. So I'll go ahead with my long multiplication. Again, both of these numbers are 2-digit numbers, so it doesn't matter which one's on the bottom. I'm just going to do 8 times 7, which is 56. Of course, I can't fit both the 5 and the 6 in that same place value, so I'll put the 6, and I'll remember the 5. And then I go on to 8 times 1, which is 8, plus the 5 that's in that place. I'll add that, that makes 13. So far I've done 8 times the 17, which is 136. Now I'm moving over to the 5, 1 place value over, so I need to fill in a place holding 0. Now I can do 5 times the 7, which is 35. I'll put the 5 and remember the 3, and then I'll do 5 times 1, which is 5, plus that 3 that's already in that place, that's going to be 8. So 8 times 17 was 136, 50 times 17 was 850. Together, 58 times 17 must be 6 plus 0 is 6, 3 plus 5, 8, 1 plus 8, 9, 986. But of course, 1.7 times 5.8 won't be as big as 986. I need to place my decimal point. Look at the digits after the decimal point in the question. There's one digit after the decimal point for 1.7, one digit after the decimal point for 5.8, 1, 2. There should be two digits after the decimal point for my answer, 9.86. But remember, my answer will be negative, so it will be negative 9.86. I know what you're thinking. This would have been a lot easier with a calculator. But remember, we are getting ready for a non-calculator exam this year. So, no calculators. Don't cheat yourself. Otherwise, you'll come to exam time and you won't be prepared. Time for you to practice this now. So, go ahead and write these numbers down. No calculators, of course, and work through your long multiplications. First, decide if your answers will be positive or negative. Then work through your multiplication. Then make sure that you put your decimal in the correct place. Go ahead and hit pause and hit play when you're ready to see the answers taken up. I hope you've had a chance to hit pause because here come your answers. Notice for question 7, I've put positive 44.0. You do not need to put the trailing zeros after the decimal point. I hope you found this lesson and exercise helpful, and if I've left anything at all unclear, please leave me a comment in the comment box down below. Also, please let me know if you think we need more practice with long multiplication or multiplying decimal values. Otherwise, just keep practicing, and I'll see you next time. Bye.